For this big time delay today. Just gonna go with audio, I guess. And I will post. Just make a copy of mine and throw it up on Canvas. Okay. Start from the beginning or particulars? Okay. First question. Based on the information given above, how many acres are in this field? This field has dimensions of 1,000 by 523 feet. Whoops. So that's just some simple math. Multiply the length and the width of our field, 523,000 square feet. And then the person's got to remember how many square feet there are in an acre. And that number is, Savannah, square feet in 1 acre. Yep. 543,000 and okay, 43,560. How many feet are in a mile? That's another handy one to know. Awesome. Okay, so 523,000 square feet in here, 43,560 in an acre. Make that division. I came up with 12 acres in this field. Okay, good there. How many gallons per acre does our sprayer apply? All right, so this is going to be that preferred formula of mine. 4084, my sweet constant, times output over speed times nozzle spacing. Okay. Output in this equation is measured with what unit, I guess, of measurement? What is it? Gallons per minute, ounces? Okay. So that output is in ounces per second. Speed, what's our measurement? Your unit of measurement there? Feet per second, so we're sticking with seconds. Okay, and our spacing is inches, 18. Is that what we had on there? 18 inches, yep. Okay. All right, so 4084. Times my output of, see what it takes, each nozzle is delivering 50 ounces in 1 minute. So I can divide 50 by 60 to figure out how many ounces per second that is. I came up with 0.83. Anybody else? Something different? Hope not. Okay, 0.83. My speed, how many feet per second? Jacob? Oh, you don't? Okay, so we are, it takes us, I said, all right, so it took us 41 seconds to drive this course that we've made that was 300 feet long. So, feet per second, if I do 300 divided by 41, 300 feet divided by 41 seconds, gives me a number of feet per second. What do you got? 87? Okay. Anyway, when you do that math, it turns out to be 7.3 feet per second. All right, times our nozzle spacing. And that gives us how many gallons per acre we would apply if we can maintain that speed while spraying. Okay. And I came up with 25.79. Okay. Just call that 26 gallons per acre. Remember the difference between calibration, and I guess the whole idea is that this formula would be ran prior to getting out there to make our application. And now when somebody says, well, if that's your rate, how many acres are you going to be able to spray with your tank? Now it depends on the size of our tank, but I know how many gallons I'm going to lose per acre I spray. And hopefully we know how many acres we've got. So the question is, all right. So how many acres will one full tank spray? And we have a 300-gallon tank, I think. Or no, yeah, 300. There's a lot of threes in this question. Okay. So I'm applying 26 gallons per acre. Yep. So 300 gallons over 26 gallons per acre. So I'm going to be able to get through 11 and a half acres of spraying by the time I run out. Well, it may seem like common sense, but a question that's often asked of somebody is, how many acres have you sprayed? Shit, man, I don't know. Boss man's trying to figure out when I'm going to be done. How many acres have you got done? You've been out there for so many hours. How many acres you finished? I don't know. Well, how many tanks have you gone through? I guess would be my second question. You know that, and you just crunch some simple numbers, and you have an idea of how much of your job you've accomplished. Okay. Okay. All right. Next question. A recommendation for 3 pounds of wettable powder. Our recommendation calls for 3 pounds of a wettable powder per 100 gallons of finished spray. So I didn't say 3 pounds of active ingredient. We're not even talking. It's just in this case pretty straightforward. We've been given instructions to just apply 3 pounds of this product per 100 gallons. Okay. A wettable powder being a dry formulation. We would have contents given to us in how many ounces or how many pounds perhaps that product contains. Okay. So how many pounds of a wettable powder do you put into a 450-gallon tank? I'm one of those ratio guys, so I'm going to apply 3 pounds per 100 gallons, and I want that same ratio. So how many pounds do I apply for 450 gallons? Do a little cross multiplying here. Or I can look at this and say, well, 450 is 4.5 times 100 gallons. So I'm going to apply 4.5 times more chemical, or more of that product. Okay, so then that you might be able to work that out a little faster in your head. But 100 times X equals 1350. I'm dividing. That is how many pounds of this product? 13.5 to throw in. Don't get yourselves wrapped around the axle when it comes to being asked the question and then trying to figure out what formula it is you need to know. Like, oh shit, just take a little bit of time and think that question all the way through. Even in the case of calibration, if a person just could not remember what formula they can use to calibrate their equipment. I mean, if you can just figure out a way to, I guess maybe actually doing a little run and trying to catch those, use some sort of a collector on the end of your boom so you know what distance you've traveled, figure out that area, what part of an acre that is, and then how much chemical you've used. Now you've got chemical use over so many acres, and you've got your rate. And a lot of times, the questions asked are much more common sense or straightforward than they appear to be once you start getting a little, maybe confused by some of the equations. All right. How many ounces do you put in an 80-gallon tank if you're doubling the rate? So, again, just something to think about here. This is a wettable powder, dry formulation. So how many ounces of that product? Dry ounces. We're not talking fluid ounces. Okay? But if I'm going to, first off, I'll just save some time, but running this, doing that, an equal ratio again. So if it's 3 pounds over 100, this time I want to know how many pounds that is for 80. Same deal. All right, in this case, X or variable. Well, first I'm going to come up with what I would need to apply standard, and then I'll just double that. Okay. So the standard rate for 80 acres would be 2.4 pounds. But I want to double that, so I'm going to have 4.8 pounds. The question asks how many ounces is 4.8 pounds. How many ounces are in 1 pound? 16. Okay. So 4.8 pounds times 16. What does that come out to? 76.8 ounces of product. Clear as mud. Okay. The 16 is ounces in 1 pound. 4.8 pounds, how many ounces is that? That's the question. All right. You've been spraying a field for 1 hour with a spray width of 20 feet at 4 miles per hour. How many acres have you sprayed? Renee, have you worked that one out yet? All right, well, walk me through it. Okay? So, I've been told that in 1 hour, I was traveling at an average speed of 4 miles. Well, I traveled four miles in that hour, right? Because I worked for an hour, I was running at a speed of 4 miles per hour, so I've gone 4 miles, straight distance. So, and we're trying to figure out how many acres we've sprayed. So what I'm thinking of is a width times a length that I can figure out acres. What should I do for length, knowing that I've gone 4 miles and 1 mile is 5,280 feet? Okay, 1 mile, 5,280 feet. We've traveled 4 because we've gone 4 miles per hour for an hour. Okay, so this is going to be the length. Feet. So now what do I need to know? What's my next step? Hoss? Yep. My width is 20 feet. So the area that I've covered, a 20-foot width, now granted, this is going to be a rougher calculation of what we've done, because I'm assuming that you haven't driven 4 miles. We're probably not going to be driving 4 miles straight line, no turns, but in that hour, an hour's a pretty good time to come up with an average. You're probably going to have a few turns in there, but this is basically the best that we've got right now. If you're able to figure out what that, I guess what your constant speed is and exclude those turns, more power to you and more accuracy to you. But in this case, I mean, and this is definitely a more real-world scenario. If somebody's applying without any measurement equipment like a GPS monitor or something. But I know what the distance I've covered is. Figure out that area. So 422,400 square feet. Divide that by 43,560. 9.7 acres. All right, so then ask how many feet per second we're traveling. We were told that we're running at 4 miles per hour. How many feet per second? So remember, this is how I remember. I remember that 88 feet per second is the equivalent of 60 miles per hour. So when I'm going from miles per hour to feet per second, I'm going to have, I expect a larger number than I get in miles per hour. So 4.5, do I multiply that or divide that by 0.682? I want that number to be larger. So I'm going to divide 4 miles per hour by 0.682. Just a little under 6 miles per hour. Knowing that I've got some turns in there, I might say, 5 miles per hour. Oh, feet per second. Whoop. All right, so my bad. 4 miles per hour or 0.682 is 6 miles per hour. True story. Okay. No, anyway. Not miles per hour, but feet per second. I think that these ones have been a bit more straightforward, or I guess, kind of a little easier to wrap our minds around, but none of them are difficult. Number 4, though, is one of those percent mixtures. So the question is, how many pounds of a 25% wettable powder? What does 25% wettable powder mean? Yeah, so by volume or by weight, however you want to look at it, 25% of the content is active ingredient. Okay, so how many pounds of a 25% wettable powder must you add to a 100 gallons of water to get a 1% mixture? Right. In this case, let me just write her out. Can I erase this here? Okay. So they're asking us, they want pounds. Okay, keep that in mind. We want our answer to come out in pounds. They're saying how many pounds of this product do we mix. All right, so all right, this is gallons wanted. You could also say this is our tank size. Times the percent active ingredient. And it's percent active ingredient, or I guess percent mix, we could say. They're saying, percent AI, we'll say, this is the mix that they're wanting. Because what they're saying is, I guess what the question is if we've got 100, I guess in this case, we've got a 100-gallon tank. We want a 1% mix. How many gallons? How many gallons is 1% of 100 gallons? Just 1 gallon, right? so that's what we're figuring out here on top. So it's 1 gallon, we figured that out. But then we multiply by 0.83 because we want to know how many pounds of that product, there are 8.3 pounds in 1 gallon of water. So we've got a gallon. How many pounds is that going to be? 8.3. Okay. Now we've got a product that is 25% content active ingredient. So this is going to say, all right, we've got a 100-gallon tank. 1% of it is 1 gallon. By weight, that is 8.3 pounds. How many pounds of product do we add of something that is composed of 25%? So I know that that's going to be, it's going to be 4. Well, let's do this a different way. I guess if that was 100% active ingredient, as some products are, I should probably just stop and work my way through the equation. But you see here that we're coming up with how many pounds are needed on the top. Below that, we've got something that in 1 pound essentially is 25% active ingredient, but I want to get up to the poundage of that whole product that I need to get that 1% mix of active ingredient. Okay. So this is 8.3. I want 8.3 pounds of active ingredient in the mix. My chemical is 25% active ingredient. In that case, I came up with 33.2 pounds of product to get that mix. You guys comfortable with that? Okay, that's about as tough as it gets right there. And sometimes you're given how many pounds of active ingredient there are per gallon, something along those lines, but we just sort of rearrange our equation. So the next one is like that. We've got a liquid this time. Last time was dry. It makes sense that we're coming up with pounds. In this case, we've got a liquid. The emulsifiable concentrate has 4 pounds of active ingredient per gallon. Okay? Your tank holds 250 gallons. So how much of this concentrate must be mixed into the tank to get a 5% mix? All right, once again, gallons wanted or my tank size, 250. I've got I'm wanting a 5% tank mix, so that's 0.05. Up here, of course, this is 1%. That's 0.01. I guess I didn't work that out necessarily, but okay. 8.3 pounds per gallon. And this time I'm told that I have 4 pounds of active ingredient per gallon. Instead of a percentage, they're giving me, content another way. 4 pounds of AI per gallon. So how many gallons do I need? 250, 5% of 250 times 8.3, 103. Divided by my 4 pounds of AI per gallon. 26 gallons of product. Okay with it? All right, let's look at number 6. You intend to spray 40 gallons per acre. How many gallons do you need to spray an area that's 436 feet long and 20 feet wide. Let's just talk about this one. So figure out my area, right? Figure out how many acres that is. I've been told essentially what I'm calibrated at, 40 gallons per acre. So figure out how many acres I've got there, and then multiply that gallon per acre by how many acres I've got. We're there. Anybody? I didn't work that one out because I figured we could talk. What'd you get? Okay, so wait. How many gallons? Yep. So in that case, so you got about 5 gallons. So it sounds like we sprayed about roughly an eighth of an acre. Just means that 5 gallons is an eighth of 40. Just kind of, so I'm guessing. All right, is that one okay? Is that me working it out on the board? If your spray equipment has a spray width of 22 feet and is operated over a distance of 660 feet, 3 gallons are used, what is the gallon per acre being applied? Straightforward again. 22 times 660 gives me the acreage. That acreage divided by the gallons I've used tells me how many gallons per acre we've applied. 9 gallons per acre, is what you guys came up with? Okay. All right, a circular pivot irrigated field has a diameter, the length all the way across, that is 2,633 feet. How many acres is that? Sounds like a full circle to me. How'd you figure that out, Jason? Okay, so diameter 2633. Our formula for a circle, for the area of a circle, is pi r squared. So I need my radius, which is 1/2 the diameter. Okay, so what does that radius come to? If anybody ever asks you how far it is across a full circle pivot, 125 acre pivot, 1316 is 4 feet shy of a quarter mile. So you could say it is a half a mile across that, all the way across the pivot. Okay, so my radius is 1316.5. Pi times 1316.5 squared is the area. Okay, what does that come out to? Anybody have the area handy? $544,000. 5,440,000. And what number do I divide by? All right. Divide by square feet an acre. Came up to 124 point something. It's 125. 125 acres in that pivot. Okay. What's the last question? Somebody. You have a 300-gallon spray tank, and you are spraying a field that is 2640 by 2640, applying 30 gallons per acre. How many times are you going to need to fill that tank? Times. 16 exactly. Remember that it may not be if you got a decimal number, you might have to do a last partial fill. So if you get 16.2 as an example, you're not going to have enough chemical with just 16 refills or 16 fills to get it done. You are going to have to fill a 17th time. Okay. It did it? Okay. Okay. Got a square field. 2640 by 2640. How many acres is that? 160 acres? Everybody comfortable with calculating that? We are applying 30 gallons per acre. How many times, well, I guess, how many acres am I going to get to spray on one tank? Hmm? 10. Yep. Okay. All right. Well, okay. So so we've got a 300-gallon tank. We're applying 30 gallons per acre. All right. Sweet. That is, I'm going to get 10 gallons at that application rate, or excuse me, 10 acres at that application rate. Right? I've got 160 acres. Pretty good math, though. I guess that one works out just right. Remember, think about yourself in the cab of that tractor or pulling that sprayer. The idea that you're not going to have any overlap at all, especially if you're not using guidance equipment, is slim to none. And so buying just enough chemical, even though that is the suggestion, so that you don't have any excess chemical that you're not sure what to do with at the end of the spray job, you may end up being just a little bit short. So, factor in, if you know what percent overlap, or I'm just talking about like when you go to buy that chemical. You may be working out a question like this. All right, I've got a 300-gallon tank. I'm applying 30 gallons per acre with that sprayer. Okay, this is how much chemical I need to go out and buy. Well, might want to get just a little bit more to compensate for that overlap that's going to happen in the field. Even if you are running guidance equipment and you're like me and you get distracted and all of a sudden you start to kind of drift off course, but you're trusting your equipment, and then you realize that you're drifting off course, and now I know that, I've used excess chemical. Not only that, but unintentionally, and it's what everyone does when they build in a little bit of overlap and they're spraying without guidance. Maybe that's a little 5% overlap, but in the end, 5% of your field has received twice the recommended rate. It's not really taken into consideration all that often, but that is the truth. Okay. So that's all I've got for today. And tomorrow, I guess I'll give you guys I'll throw out a little printout of what subjects need to be looked at. We'll go through that. I would like you guys, as always, to ask more questions than I do, but
Do we need to turn this in?
yeah, turn that in if you're all done.